Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we will conclude the section on plotting bivariate with a categorical response, where we have a binary response variable and a numeric x variable. All right, or predictor variable. So we'll scroll down to 8. Categorical response. There's no R Markdown file, therefore the assignment must be in the outline. And if we go over to RStudio, I'll sort of pick up where we left off, but I'll page up here to the rubric for class 8. In the last video, we did a bivariate bar plots, and in this video we will do scatter plots where the numeric, response variable is binary, and we have a numeric x variable. All right, I'm going to, however, start this video by interpreting the previous plot, which I neglected to include with the last plot. So I've paged down. I'm going to go over to the project file. And this is the plot that I am interpreting. And let's look at the table of proportions that relates to this plot for a moment. And that's this one. And the main feature here is that for people who do not have depression, their nicotine dependence chance is about 9.1%, whereas people with depression, their chance of having nicotine dependence is 22.6%. So what I did is I took those proportions, and when I paged down to this plot, I just interpreted those proportions. And here's how I wrote it. I wrote, when a person has depression, they're more than twice as likely to have nicotine dependence at 22.6% than those without depression, 9.1%. Okay, that's a nice way to interpret the previous plot. All right, on to this assignment, or this part of the logistic scatter plot. So let's scroll through the plots to see some examples. I will go on the website above the timetable to last year's set of assignments. Now there's one big catch on creating this plot. It is that when we create this plot in a straightforward way, that is, we assign a numeric variable to the x-axis and a binary factor variable to the response y-axis. This makes a fine plot. Okay, I've created a little bit of jitter here so you can see that people with nicotine dependence, their mean total numbers of cigarettes smoked on the x-axis tends to be a bit higher than those without nicotine dependence. We think, I don't know, that's my impression from this plot so far, since there's so many values up here at 0. And to create this plot is pretty straightforward. ggplot, we've got the data set here. We assign to the x variable a numeric variable. To y, we've got the tobacco or nicotine dependence variable, and then we plot the points, jittering them, and we jitter the heights. In this case, I did it at 10%. Okay, so the 10% up and 10% down, and the alpha of a quarter makes the points a bit transparent because their opacity is 1/4, and when I print it, I've got my plot. So it's as simple as it can be. But what we really want, ultimately, if I scroll down to a lower plot, is to overlay a curve that helps us visualize basically the probability of tobacco dependence given the number of cigarettes that you smoke. Okay? So for example, if you were smoking, I guess this white line here is about 500 cigarettes. The chance of a random person who smokes 500 cigarettes having tobacco dependence would be, let's see if this is point. You know what? We need better access labels here. 1 is up here, and we really just have sort of 0 and 1. But 500 cigarettes, so that means this white line is 0.6, maybe 0.65. Okay, so there's a 2/3 chance that you have nicotine dependence if you smoke 500 cigarettes per month. That perhaps seems low to me, but there we are. All right, so the real trick is that we need a way of creating a 0-1 variable. So converting the data that we have to either have a 0 or a 1. And it actually is pretty easy. There's several ways of, there's several scenarios to be able to handle. The first scenario, okay, so here I discussed collapsing a variable to a binary variable. And in particular, it needs to be either a 1 or a 0, okay? A numeric binary variable. So if you've got a numeric variable, such as someone's age, right? So there could be an example where, you know, is someone legal to drink alcohol or not? So there's variables in here about alcohol dependence, I believe, and there's people's ages, and if someone is older than, older or equal to 21 years old, then we can call them legal. Otherwise, we can call them illegal to drink. And we can create a similar binary variable, which I'll say binary 0-1 in the variable name, to indicate that the values that this variable takes is actually 0 and 1, which means that it's the right variable to use when we're creating a plot. So I can do the same code. If someone's age is at least 21, then give them a 1 for legal or a 0 for illegal. So if I look at, if I scroll down just a little bit and look at the data set and select their age, the alcohol binary and alcohol binary 0-1, we see that depending on their age, they're either labeled legal or illegal, and the binary 0-1 variable has either a 1 or a 0. Great. So then I can use this variable, binary 0-1, for the appropriate plot. If you have a categorical variable, like tobacco dependence, we just need a way of saying if your tobacco dependence is equal to the label tobacco dependence, then put a 1, and otherwise put a 0. Now I think this works even for NAs. Okay, so that's pretty straightforward. I say here, sometimes it is necessary to make your variable a character type first. So this is actually exactly the same code as above. And so if this if-else function did not work, then wrap your variable, this tobacco dependence, with as character, and then assess whether that equals nicotine dependence, or whatever the label is that you're assigning to success. All right. Another situation is if you've got a multi-level categorical variable and you want to collapse that down to only 2 categories. So here's smoking frequency, and it has these 7 levels, either never up to every day. And it's the same sort of code. I've formatted it slightly different, but it's an if-else, and we're saying if smoking frequency is in the list, and then you provide all the labels of the list that you consider a success. Okay, so if you smoke every day, 3 to 5 times a day, or 5 to 6 times a day, or 3 to 4 times a day. So basically, if you smoke at least twice a week, say, then consider that a success. Otherwise, you're not smoking enough, and you're a failure. Okay, so that is the smoking frequency variable. Finally, once you've got a 0, 1 variable, like this one here, 0, 1, then you use the same code, ggplot, put in your numeric x variable, your binary numeric 0, 1 y variable, and you can jitter the positions. And then we've got some additional code to make the curve. There's this, I basically just copy and paste this. Okay, this is I'm defining a function that performs a geometric smooth line based on a generalized linear model from a binary family, which is what we need for a logistic regression, which we'll learn at the end of the semester. And then I add to my plot, which I've defined the axes up here and plotted some points, I add to that a smoothed curve. And then finally I label the plot X, Y, and title. On the x-axis I've got estimated cigarettes smoked per month. On the y-axis I've added my tobacco dependence, and I've labeled a 1 as a yes and a 0 as a no. Now I'm gonna redo this plot in a moment in RStudio, and I'm gonna improve this y-axis so that we have 0s and 1s labeled, and I'll show you how to have a little more control over the axis. Finally, I interpret the plot. I say the probability of someone being tobacco dependent, so that's the y-axis, increases as the number of cigarettes smoked per month increases. The main thing in a logistic regression, because we don't have just a fixed slope, this line actually curves, the main thing is we're going to talk about, as x increases, does y increase, does it decrease, or does it stay the same? Okay, so we're either looking for an upward trend, a downward trend, or just sort of a horizontal line that really isn't trending up or down. All right, so let us grab some code from here, go over to RStudio, and start discussing code. All right, so I've got this question about total cigarettes smoked and tobacco dependence. I'm going to grab the code associated with tobacco dependence. Okay, so I'll start by grabbing this table. So we've got a categorical variable that we're setting to binary. I'm going to grab this code, go over to RStudio, Control-Alt-I inserts a code chunk, Control-V pastes some code. I'm going to scroll down. I'm going to grab this piece of code, which is giving me my binary variable, and I'll add just a space above it and below it, and that might be everything. I say sometimes it's necessary, but was not actually necessary in this previous case. However, I feel a little vulnerable if I don't actually copy and paste this. So I'm going to put this down here, and maybe I'll just add it as an additional comment. All right, I've picked up from the last video exactly, so I'm just going to run this line of code, make sure that we've got, oh yeah, tobacco dependence is no longer tobacco dependence. I now am using nicotine dependence as my variable name. That is going to bite me for the entire semester. All right, let's run this now. That looks better in terms of having some numbers at the bottom. Okay, so my original table showed these frequencies, and after I converted it to a 0,1 variable, my nicotine dependence 4962 is now labeled as a numeric value 1. Perfect. So I'm ready to plot. I'll go over to the plot, scroll down, And I'm going to copy this, and then we're going to improve this plot. And I like the idea of having a new code chunk for the plot. Control-Alt-I, paste. Okay, so if this was yours, you'd make sure that you've got a numeric x and this binary 0, 1 y variable. And since I've talked about a lot of plotting stuff already, I'm going to just press play on here and create this plot over to the right. And tobacco dependence is not named in my variable anymore. So we'll change my tobacco dependence to nicotine dependence, and I think that's the only thing I need to change. I'm going to recall this nicotine down here. And the title should reflect nicotine. It is taking a while to finish plotting. Oh, there it goes. Okay. Nice. So I still have this increasing relationship. It's even stronger in this data than it is in my previous assignment, and that's because I have not restricted this to only 18 to 25-year-olds, but it's everyone in the data set. Okay, that's beautiful. The interpretation is going to be the same for me that we discussed at the beginning of the video. And the last part after the interpretation is I'm going to go back and improve the axis. Okay, I will bold interpretation with a double underline on either side. All right, let's improve this plot. And we have just enough space to get everything on the screen for you. All right. So, how do we improve this axis? So the first thing is, I know that I want to scale, so the help here is going to be scale underscore, it's going to be the geometric object, or rather the geometric aesthetic. It's going to be what we've encoded, and so it's going to be the y-axis underscore, and what type of axis is it? It's a continuous variable. And I put a question mark at the beginning here because I'm going to ask for help. So I click on that and it opens it up top. Scale X continuous, scale Y continuous, allow you to give lots of options. And here's some of the options. The main one here is breaks. That's going to give us the major grid lines. And then minor breaks gives us the minor grid lines. So let's use this function, change it to the y-axis, and make it a layer by adding to the plot that already exists, and then specifying the arguments. First of all, limits equals from 0 to 1. Okay, so we know we don't need to go beyond 0 and 1, but we definitely need to include 0 and 1 because those are the values we have. Then we've got breaks equals, and there's a few ways to specify this. I would probably want the values 0, 0.2, 0.4, 0.6, 0.8, and 1 as major breaks. But that is a lot to type. So there's a better way to get those numbers, and you avoid typos like I created over here with that point, comma 6. You do a sequence. I'm going to have a sequence, goes from 0 to 1 by 0.2. I'll make that a little wider. Okay, so this sequence, let me highlight it and press Control Enter. That will submit it from the editor down to the console and show us the results. The sequence of 0 to 1 by 0.2. Okay, and you can get help on sequence by doing $SEQ. The last part is minor breaks. And I'm going to do the same thing basically, but we'll do minor breaks at every point 1. And we need to call breaks minor breaks. All right, I think this is going to be a much better plot. Let's take a look. So we'll run this, and we'll make this plot window bigger. It may not like me moving this window around, as it's taking a long time to create this plot. Sometimes you can get an error down here if you fiddle with the size of the plotting area while it's attempting to plot. It's taking a long time because there are so many points to plot. There's 43,000 points. Okay, so now I've got a y-axis, 0, 0.2, 0.4. Those are the major breaks. And the minor breaks are the grid lines behind. Maybe one last thing I can do here is if I add the theme, the black-white theme, I just sort of do that up near the top. It doesn't really matter where you put it. It matters a little bit, but then we'll get a white background with light gray grid lines. And that looks pretty good. All right, I'm happy with that. Oh, you know what is interesting? We set limits for our scale y continuous of 0 and 1. But I'm noticing, right, all these points, I'm not seeing any negative values. I'm not seeing any values greater than 1 as part of the jitter, the geometric jitter that's modifying the height. And I wonder if I'm actually seeing all the points or not. It could be worth removing that for a moment and rerunning it. And page up and hit that. It's going to be hard to tell if we see something different or not. I'm going to toggle between the previous plot and the plot we're creating now for some of the rare events, for the high numbers. Like there's 2 values here, okay? Whatever value that is, 2300 or something. So let's go back and see if there's 2 values there for the previous plot. Only 1. See that? Okay, so by creating those limits, but also using a position jitter, the jitter is jittering above 0 and below 0, but the limit cut off all the values that were below 0. So there are some unintended consequences if you don't really pay close attention. Okay, so that makes this plot better, the one without the limits on the scale y continuous. All right, I think that is everything. The main thing I believe in this case, I'll knit this while I finish talking, is in the previous year's assignment, find your scenario. I just jumped up to the table of contents. Find your scenario for the logistic scatter plot about whether you've got a numeric variable that you have to go to binary or a categorical. And if it's categorical, do you have just already a binary categorical, or do you have more than 2 categories and you need to collapse, say, 3 categories to be called a success or a 1 and the rest to be a failure and no. Okay, so that is everything for this assignment. I'm finishing plotting it. Maybe the other detail is, depending on what this plot looks like, you may add chunk options to scale the plot. Let's go over here, refresh the browser window, and take a look at our plot. And it's jumping around a little bit. There's our previous plot. There's our current plot with the interpretation. let's make sure our interpretation, this interpretation of course was from last time. So the probability of someone being tobacco dependent increases as the number of cigarettes smoked per month increases. Okay, so we've got this increasing slope. The logistic curve model probably doesn't apply at or near 0 cigarettes. That sort of makes sense, because if you smoke 0 or almost none, we probably don't have a probability of being nicotine dependent, though I suppose there's other ways of acquiring nicotine dependence. Look up here at the title. Likelihood of nicotine dependence increases with number of cigs. Okay, so we either need to make this plot wider, or we need to put a line return in this title. Why don't we do both, so I can show you how to do that. We are down at line 1170. I know that if I go to the very top, I press Control Home. If I go to the very top of this document and then page down to the first code chunk, that in these options, here, let me clear this window and then I can resize it quickly. In these code chunk options, there's a figure height and a figure width. So I'm going to copy that, and then I'm going to scroll back down to 11 something or other. Looks like I'm getting there. Okay, here we go. So there's my default width, and I'm going to make this 8 inches for figure width. The height seemed pretty good. In fact, it doesn't even need to be this tall. We could make it as narrow as 3. Okay, so then the other part is, let's also just put a line return in here. We'll say likelihood of nicotine dependence, new line, remove the space, increases with the number of cigarettes smoked. And now that I've got a new line, I've got more space to spell out cigarettes. Cigarettes. All right, and let's go ahead and knit this, and then we'll wrap this video. So what this is doing in the markdown window down here is, for each code chunk it sees, it's interpreting it. It's letting us know that we have not labeled any of the code chunks. You can put in names for code chunks. It's sort of handy if you're debugging. It's not a critical thing for us, so we're not doing it. It's also telling us what proportion of the code chunks have finished. So at code chunk 24, we're about 84% of the way done. Whenever we set the code chunk options, it tells us what those options are. Any warnings or error messages are reported to the screen here. So it is letting us know that it's, this smoothing is just giving us a simple regression model. All right, let's head over to here. We'll refresh the window, and it's wider. We've got 2 lines for the title. Looks pretty good. In fact, I sort of like it much better wider. It makes the sort of emphasizes more what this range of number of cigarettes is. So that is the end of this assignment. I hope yours looks at least as beautiful as mine does.